Okay, it's recording now. Okay, good. Okay, hello, this is Ray Lutz with Citizens Oversight. And so I'm going to today go through an overview of ballot image auditing and give you some idea of how it actually works out from the standpoint of somebody who's trying to actually use this as a user. So as we see here, I'm going to have a few use this as a guide for us to go through it, and then I'm actually going to show you how it works with trying to compress time and skip over the time that it takes right now. But essentially, first of all, we do know that elections are essential to any democracy, and unfortunately they have been fixed throughout history, and as we know right now, there's a tendency for them to be temptation for people to be fixing these elections. And it's in very, very different scams all the time, whether it be actually monkeying with the totals, or making it hard to get to the polls, or making it so that applications don't work. We had the situation in Iowa where everything wasn't working. And in the past, some of the groups were, for example, clogging up phone lines so that no one could make calls to voters to tell them to come to the polls or something. So there's all kinds of different ways of doing it. What we're going to look at here is simply how to make sure that the totals are correct once we get them in our hands. The machines can make errors, but also human errors. A lot of these are human errors, easy to make because of the complexity of these things. And basically, here is the guideline: is that auditing elections is essential to thwarting these scams and machine errors. This, it turns out, is our best hope to making sure that these elections are done correctly. Now, there's different options. And I will say to the viewers, there's some people listening in on the Zoom video, so we may have some questions from them as we go through. If those folks would please mute your microphone until the time comes when you're going to be speaking. So basically, you hear about retabulation. This means that they're just essentially running let me get this so that it's not, I guess I just got to go up like that so you don't see all those tabs. They're essentially running the ballots back through the same machines that were used to begin with. Just to make sure that things were, maybe batches weren't left out. It does cover some faults that could happen. And a lot of times they then review overvoted and undervoted ballots. So if you vote for undervoted, means that you are the voter voted for too many options in that contest. And if that happens, then that eliminates their vote completely in the contest. Sometimes those overvotes are hesitation marks where they didn't quite darken it in. They just rested their pencil there, maybe were trying to make up their mind, and then really darkened in the other bubble. And then sometimes the machines counts that as an overvote. So we don't want their vote to be invalidated just because they did that. And then undervoted means that maybe they made a mark that was too light and the machine didn't pick it up, but it should have. So these are all voter intent. This doesn't really, it only pick up some of the voter intent things. Now, a big area of recent development is in how to deal with hand counting samples and then comparing the results that you get with hand counting to whatever the official results were. We have a few approaches there, like fixed percentage sampling. The 1% manual tally in California has been an example of that, which does not escalate if it, and there really isn't much defined in terms of what if they find some discrepancies. They usually just don't report them very well, or look into them and fix the things that are in the audit that they're doing, rather than actually looking into a really bad problem, because they don't really want to find it. Just think how bad that would be if they find it, then have to go back and do a lot of extra work. So Actually getting a fixed number of samples may be even a better way to do it, because once you get into, unless it's a really small district, but generally speaking, a fixed number of samples is kind of a better way to go, because it would say, okay, well, I'm going to at least be able to deal with elections that are of this this low of a margin, and it will take care of it. Whereas a percentage based, it depends on how big the district is and how big the number of how many ballots are involved in that particular contest. And then escalating the number of samples based on sample error calculations. This is what the risk limiting audits are about. So essentially, when they say risk limiting, they're talking about limiting the sample error. It doesn't eliminate all the other risks. It just limits how far off we might be due to sampling error. There's other things that are going on, like ideas like polling voters as they leave polling places. But it's hard to do this because, number one, it's not compatible with vote by mail voting, which is pretty predominant in a place like California, which is around 65% or more, and states that don't use polling places. So you can't do it there. I guess you could contact the voters later. It's very hard to have enough coverage for statistically significant results, and it's difficult to then use those in court, because then you're relying upon what the voters say. Now, the ballot image audits are review of images created by the ballot scanners, either by hand or automated. You could review them, yourself by looking them over. People, teams of people perhaps, or group type sharing of the information over the internet amongst many people and then covering it all. That'd be one way to do it, or you can do it with a automated review. So just quickly comparing these, the sampling inspections have some downsides, even though they do deal with the original ballot evidence, which is a good thing. Unfortunately, the ballots are not generally available to the public for review. So when we say we're going to use the original ballots, what we're saying also is we're going to turn it over to the election officials to do everything. And then that means that we have to provide intense oversight of the procedures to make sure that they're doing it right. And they've proven time and again that they don't either know what they're doing or they just want to cut corners. The risk limiting audits introduce even more complexity into the process, and it may introduce more risks that the audits can be defeated just because they're so complex. And from my review of what election officials do anyway, I don't know if they can handle that complexity. Now, here's a big thing. Officials are auditing themselves, all right? So they're going to strive for a clean audit, and then they may innocently fix it up. So like if they have say a batch of ballots that didn't quite match, they'll review that, fix the numbers in the computer and say, okay, now it matches, we fixed it. But that actually only means that the problem could be much more widespread. And the question is, will they then look into the widespread problem or just stop right there? Yeah, knowing how these work, they'll probably stop right there and say, we've cleaned up the audit, now it looks fine, and then not continue. They take a lot of time and effort, and they tend to take shortcuts. And like we found, leaving out large groups of ballots. And this was the source of our lawsuit in San Diego, because they were leaving out 285,000 ballots from the audit, which is about 30 to 40%, about 37%. That's a big chunk of ballots to leave out, and yet they think it's fine to do that. Mathematically speaking, it isn't a valid thing to do. So the more complex the audit is, like the RLAs that some of them are very complex and require very few ballots to be reviewed, but then you have to get real handle on everything that's there. The audit will have these hazards of not being conducted properly. I see that the frame rate is, the frames are being dropped. maybe, let's see here, if I can fix that. Don't see how. I'll have to continue to monitor that and see what happens. All right, so now getting over to ballot image audits, they use images that are produced early in the process is the best way to do it. And just by doing that, we'll thwart any hacks or tabulation changes that, modifications that would happen after that point. It would catch that. Of course, it's not going to catch the issues of whether the ballots were changed up front. That's pretty hard to do. You have to get into the machine to do it, into the individual scanners. And now what we're trying to get is ballot image security mechanisms that can make any changes to the ballot images infeasible to do after that point. And so those things are in process, are not in place right now, so we would have to hope for better in the future. But I think for the most part, we're catching a lot by doing these. Now, the status in general is that we had a firm, Clear Ballot, that was offering a service for a fee to election officials, been used in places like Maryland. They did a study actually comparing the various ways of doing RLAs, also not so much RLAs, but fixed percentage audits with ballot image audits. And also, we've had a number of counties in Florida and other states that have conducted audits through Clear Ballot. I think Leon County did it there. And what they were doing was actually rescanning all the Clear Ballot has been, they include rescanning all the ballots. That isn't really what we had in mind. We want to actually use the evidence from the election that they were using themselves, because that gives us the opportunity to actually analyze what they're working with these images, rather than rescanning them and working with fresh data. But there is an argument for doing that too, as you'll see that sometimes the ballot images are pretty bad. The newer equipment is now generally making the ballot images in their process. And this is starting to be regarded as information that should be retained by the officials. And indeed, many districts are making the ballot images available routinely. We've been able to get the Dane County, Wisconsin ballots for a number of elections. And now, really happy to see that San Francisco, in their last election, has made all their ballot images available on the website. So that will eliminate the other districts in California from saying, "Oh, we can't make them available because they're sealed," or some other notion. We also have a ballot set from Wakulla County, Leon County, and we also have, I don't know if they're making them available on a regular basis, but Volusia County in Florida also has, we have a set from them. And then Audit USA and John Brakey have been working to ensure that the images are preserved. They've been a good energy behind making sure that we can get to these, because it's really important for our process to work. We need the ballot images and the cast vote record data.
Ray?
Yeah. Hi,
Emily, could I ask a question before you go on to the next section?
Okay, yeah.
So you talked about that some of the screen you have on there now, the top bullet point you have, newer equipment is now generally making ballot images in their process. And as my understanding is that that's true of multiple kinds of newer equipment, but that some of them, specifically the ballot marking device, some of the ballot marking devices, the newer models, are making ballot images that are actually not trustworthy. Can
Well,
you speak to that?
yes. So we can outline these. For example, the leading company is about 47% is election systems and software, ES&S. They do make the ballot images in their DS 200 precinct scanners and their DS 850 and other central count scanners, and their ballot marking device. I can say the ballot marking device makes a smaller ballot summary, but it's scanned at the precinct as well. Ballot summaries are scanned, and so that's another notion there. So that's then you have Dominion, which is the ones that are San Francisco has the newer stuff, and I see also that San Diego is using these. They also have, and we've encountered two types of BMD with them, a BMD that uses barcodes, a barcode type, and a hand-marked looking ballot. I should say what would be a device marked, because they look just like a hand-marked paper ballot, but their bubbles are colored in, and sometimes they actually make them look like human scribbles. And then you have the other, I guess, very much a trailing, but heart is used by some, and they have the same type of their ballot marking device uses regular ballots. They look just like a regular ballot, but they're device marked. And then you have VSAP, which is the LA approach, which creates only a paper record at the polling place, but creates images later. So your point here is that, yeah, the images are created later, and so they're not as reliable because there's this time lag between when the voter casts their ballot and it becomes imaged and a preliminary count made at the precinct to a later count. And so we're going to have to follow these ballots, but I mean the ballots themselves are not reliable at that point.
Right. So if the ballots themselves are not reliable, including where there's a barcode and the barcode is what's counted and the voter can't read the barcode, auditing the ballot images is not going to be helpful because the ballot images may not be correct.
No, that's not true. I mean, it's not an you're right in that it's not as good, but what it does do is it lets us catch anything that happens after that point. So once the ballots get imaged and they're put in and they're totaled up, somebody can't go back into the totals and change those totals. So what I want to do though is just recognize that nothing is absolute, and that how far back do you go to what the voter did? Yes, you have that. Say you're doing paper sampling in a RLA, you still have to rely upon all the security of that paper, which is unreliable too. They're very unreliable because you can take a pencil and color in a mark. And on a regular paper ballot, you could have a bubble there, and that bubble, if you color in another bubble, then you could make it an overvote and do away with that person's vote. So if you wanted to impact the election and you had access to the ballots, you would just color in a bunch of bubbles for the candidate that you don't like, and then turn them in. This is what type of thing happened in North Carolina, and they got convicted for this sort of absentee ballot tampering could be done here in California as well, because they leave it up to people that are other than the voter to bring them in. So we have a lot of unsecure aspects, but after the images are created and then all the way forward, then we're able to at least check that thing. So you can look at it as a consistency check of at a certain point and then on forward, rather than saying this is going to be the end all of end all audits. It only audits what it can. Any of these audits only audit what they can. And we have to say and keep in our mind that an auditing procedure in itself, like when you say, well, this is a risk limiting audit. Yeah, it's a risk limiting audit only of a limited set of things that can be done. Yeah, Jim, do you want to say something?
Addressing the idea that it doesn't help the two ballot images audits because they may have been fiddled with. My first exposure to ballot image thing was for KPFA radio station board. The first ballot I picked from the internet, because they put all 3,000 up, had a smudge on it. And I was able to verify that the smudge got counted. After we checked more and more, we were able to go back to the people running the election and say, you got to hand count all of this, because your software wasn't any good. So that helped.
Yeah.
And the second thing is, it would permit us to do for, say, LA, which has QR codes in the upper left-hand corner, to cross-check the QR code with whatever was written, printed on the ballot. And you can go in and read the QR codes if you know what you're doing, and just start cross-checking things. And one thing, when I get a bunch of LA ballots, I want to make sure is that if a ballot is from the same precinct, that first QR code, which is supposed to be ballot style, is exactly the same for every precinct. If it's not, then we need to ask questions. So this is not totally useless. You can do stuff.
It's far from totally useless, trust me. And what we've done is we've actually been able to, I'll show you in a minute, is decode the ballot summaries from the express vote machines, and we look at both the barcodes and what's printed. We read what's printed and verify that the barcode matches. The barcodes in the ES&S system are very hard to index because you have to know exactly what ballot style you're working with, because it gives you the coordinates of the bubble on that ballot style, and the number of the ballot style on the barcode version doesn't match the style that's printed on the ballot. So it's very, very hard to index those together. Even though they say it can be done and they're the same, it's just not even true. Okay, so let's move down then, and I'll show you a little bit more about how this works. Well, we've been developing a cloud-based ballot image auditing service we're calling Audit Engine. And then I'm going to show you some of how that works. Right now, we're looking for election officials who want to try it on a pilot basis this election. We're not ready for it to be deployed just on an unlimited basis, because there's just a lot of kinks and edge cases that still have to be dealt with. Organizations may want to use it for an independent check on the results if we have an organization that is interested in providing oversight for the elections. Campaigns may want to do it as a check. This is other than the election officials who may want to use it if they're allowed to in their laws to use an auditing ballot image audit. Then maybe they want to do it on a pilot basis so that eventually they will be able to use this as their primary auditing mechanism. But also we're looking at it maybe even more so as for organizations or campaigns who want to check the election themselves and don't want to trust what has happened by the election officials. We're looking for, at this point, developers who might want to be involved in helping us to expand and enhance it. And of course, funding sources that we can use to pay for the cost of getting it up and running. Now, the overall process, I've broken this down into just really 8 steps here. We need to get the ballot image archives from the election, and these are usually generated based on by the election management system as either PDF files or TIFF files, other types of files, but zipped up into archives so that you'll have maybe 15, 30,000 ballots in one file. And then those are uploaded onto a file posting service. And we're using sharefile.com, not because we have any kind of great relationship with them, but they do offer trusted timestamps. If we can get trusted timestamps, then it's not possible to modify the file once it's uploaded and change the date to an earlier date. So if you have a system that disallows timestamp changes, if a file was uploaded and it has a date on it, then that's the date when it was uploaded, and it wasn't changed and then uploaded and the date changed to an early date, so you think it was uploaded earlier. So this is key for us in our methods of keeping control of these and making sure that they're not modified later. And of course, we do have an account, so somebody who doesn't have one, they can upload the files to our account. Usually they have a pretty good uploading method, so it's easy to upload these big files over a period of time. We try to keep them, the archives to around 5 gigabytes. And if you make them any bigger than that, it just becomes a pain to upload and so forth, because sometimes the line gets dropped. You got to keep it in little bite sizes that you can actually deal with. Each one of these may take an hour or 2 to upload, depending upon where you are. So that is a big chunk of time, is just getting these ballot images uploaded and available so that we can work on them. Then you submit a job to our site, and as I mentioned, the site really isn't fully functional, but I'll show you how it would work based on excuse me, just running locally. And we also need, as a first step, is you will be generating this election information file. And what we need to know is details about the contest names as we find them in the CVR and on the ballots and in the options. Now, we're working on this, but a lot of times they're just a little bit different, and it's hard to make the connection. And we're working now on working with NLP, or natural language processing. And so we're hoping to be able to pair these up is in a little bit better way. Is something that we're looking into adding. So essentially the problem is that you'll have simple things such as mayor, the city of, say, Madison, and then elsewhere you'll say Madison mayor. All right, and somewhere else you'll say mayor, Madison mayor. Now those are the same, and it's easy for humans to make the connection, but it's a little bit more difficult, and the cases really are just so diverse, especially when you get longer names, that we need a way to pair these up. And it actually is an issue that comes into all types of auditing, because you want to make sure that you're applying the votes from the ballot item to the correct tabulation. So you want to make sure that the tabulation column, if you will, on a spreadsheet is the right one that you're choosing for that right thing. a lot of times we'll have in the ballot set from Dane something like town supervisor. Well, but it's of a certain town, but it doesn't say that on the ballot. So we have to know that when we're using this particular style of ballot, that this word town supervisor on the ballot means not just town supervisor, but on the cast vote record, it is the town of Albion supervisor. Those two things are the same, but only on certain types of ballots, certain styles. So it's a very, actually a much more sophisticated issue than we ever imagined when we first got into this. Is matching up names. And this natural language programming is a new area of computer technology that we're now looking into using, so we don't have to have such an exhaustive list. But at this time, I will show you what the list looks like in a typical case. Here is a election information file for Wakulla County in Florida, and they're not too bad there. We had to add a few things though, because, for example, in the cast vote record, it says only First District Court of Appeal on these contests. They're all the same, but they're actually different. And so we had to amend that to say First District Court of Appeal Judge Harvey J., Stephanie Ray, Brad Thomas, because in the cast vote record, the names are all the same. They're not unique. And neither are the things on the ballot. They're all different. The only way to figure them out is to look into the description. Shall Justice Alan Lawson of the Supreme Court be retained in office? Well, that's not one of these I'm looking at. Shall Judge Harvey J. be retained in office? So it is at this level where what we have is a few columns here, and then what we see there. And that's one way to do it, is just create this list. This works. And so for right now, that's how we're doing it, but we're working on that issue. But for right now, we do need to have the election information file. Let me just show you one other one, which is for let's see, for Dane. So this one is a much bigger problem. Wakulla County is only 14,000 ballots. This is 154,000 ballots, and it has 191 different styles. And as you see, these line items are basically all contests, and there are up into 300 different contests. So it's a pretty complex election. And a lot of times you will have, on the ballot, it says Alderperson District 9. And we need to know that it's the Madison Alderperson. You know, we need to know that it's village president on the ballot, and it's the village president for the village of Belleville. That's one way to say it. Another way to say it is Belleville village president. So this is where we believe that we can make it easier and maybe get by and not have to have these files. But we do need to know what are the contests in the election and what are the options for each contest. We do need to know this basic information. And we also do need to know, because sometimes it's hard to read the ballots, if you do have question type ballots, I don't know if you can see that, but basically there's the full text of the question. We want to have the full text of all the questions. This is information that is available just by looking at the ballot. But you only have to look at ballots that happen to have that contest on them, so that we can have that, and we can then create the templates. So we have this information file, and then we pre-process the cast vote record and that information file and check for inconsistencies like contest names that are the same, not unique, so we need to be able to tell them apart. Any contests that don't have names at all, stuff like that. And then we go into creating the templates. Creating templates means that we take the ballots, we start scanning through them, and we combine ballots of the same style and add them up. Essentially, at every pixel, we add that pixel up, and then we threshold it down, which basically erases all the non-printed marks on the ballots. It could give us a blank ballot to work with. Then it goes through analyzing the structure to find regions of interest or ROIs, and then we map the contests and the options to the ROIs. And then we create these red line proofs. What'll really help is if I show you the red line proofs for let me get this over here. And what we have is a case here. I'll go back one. And we have the styles. Now, I didn't do all the styles in this run. There's 191 different styles. We'll just choose one. And what it did here was it took these ballots that you see and added them together and created a master template, which is not going to have, some of the stuff is gone now, and some of the things are a little bit clearer. What they did on these ballots, so is let me get this in a position where it can be seen, is that they put this gray background on the ballot. And a lot of times, if you just look at a single ballot, you can't read it at all. It's scanned at a threshold that's so high that the background and the foreground, you can see, no machine is going to be able to read that. But once you, and in pretty much all of these, it's just as bad. So you can't read that. But you can do it a little better by adding them up, because once you add them up, then the background is kind of dropped back. Any of the notations that you see that used to be the signatures and stuff are gone. And then what we do is we map the contests, and we end up with these red lines. And what you see here is that we've said, okay, this box here is for the justices of the Supreme Court. You can verify that indeed it says justices of the Supreme Court. It's a correct contest. And then here's Brian Hagedorn. And you can see the rectangle around the oval, that's lined up with the oval, and you can verify that everything looks correct as it should, and these are matching. So not too hard to then just go over these, have a human being take a look at these master templates for the 191 different contests styles in the election. Let me see if, I guess I didn't on this other run, I didn't have all of them. Well, there is many of them here. I think the styles are fully created on this one. Now, in the job file, I'll show you the job file. You may have to, we've got a thing for, and I'll show you the case when it really does need to be helped. We have this is the job file, which gives us the sources of the image archives. You list those, and in this case, there's 5 different zip files. There's about 12 gigabytes of information. We've named the job. We have cast vote records. There's 2 files that are Excel type spreadsheets, and they're limited in size to 100,000 records because otherwise they won't open. And that's what we're getting. Then we have the election information file. Now, there's some other information here that goes along with support. I won't go through all of it, but I just want to show you an example of where we had to help it along with these overrides because sometimes we just don't have enough information. So in style 53, we had trouble with Montrose Town Clerk. And let's take a look at style 53 here. And you can see there we only had we had one ballot. We have one ballot, the template, and the red line. And basically, these ballots are so bad that we cannot read them, what the contest says. But we can read the options. And so that's what the system does. It actually mostly reads the option. Because when you look at this ballot image here, with this background, and that's what we're recommending, please do not use a gray background because we get this horrible scan out of it. But even with that, we're able to take a look at Brian Hagedorn and say, okay, well, we know what contest this is because these are the options for this contest. And then it comes down here, but you can see that for the one that we're having trouble with, we can't read it and there's no candidates, none. It just says write-in. So it's not really possible for us with just this information to know for sure that this is that contest. And this was when apparently it was skipping over that one before. See, it actually stopped here and did not complete it because it needed to know for style 53 that this was a place when it was going to pick that up. So if we don't have this sort of really bad ballot design where we can't read things, and especially I've never really seen this. I guess they do this in Wisconsin where they don't have any candidates and you can still have the write-in. They're struggling to get the town supervisor for Montrose. That's an example of when, yeah, sometimes amongst these we have to give it a little nudge at this point when you have really bad scans. But then for the most part, it goes on. Let's go to the next step. And the next step is that after the red lines are reviewed, then we can say, yeah, we paired up what's on the ballot with what we're going to have the machine decode. Then we can go through vote extraction. What the vote extraction does is based on those red lines where you saw each little mark, it takes each ballot and it reads the other thing on this type of ballot is that this left edge where you see these timing marks, some of them are longer than other ones. That's actually a barcode, a kind of a custom-made barcode. And those longer and shorter little timing marks encodes the number 53. And we've learned how to read these and come up with this number, but we can also verify it by reading this most of the time too. That gives us the style number, and still with the style number, we have to know for a given style what are the contests and what are the options in that style. Well, we know for each contest who the candidates, what the options are. That's a given. What contests are on any one style depends upon what. For this, for example, this is the town of Montrose, and there was only one ballot in this entire election from this in this specific style. But it means what contests are on the ballot. They do tend to put these contests in the exact order of the cast vote record. which is handy. We do need to know what the order is too of them, but it's a problem we haven't had to deal with because it's been the same as the cast vote record order. So when when we do vote extraction, we don't use the cast vote record at all. We don't look at the cast vote record that they developed. We actually do it only with those red lines and the ballots, and then create our own cast vote record essentially. And then we do cast vote record comparison. So we take our output and we compare it with their output. Now, here is it going through right now. It's still running from earlier because we're now running this in a single thread mode, which means on this one computer at a time. And now you can see it's going through one ballot at a time. It's going through the first 20 precincts in Dane County. And this is the record that we create for each ballot. You can see in the first column here is the contest name, and then the option names, Brian Hagedorn, and the values of the pixel metric value is this next to the last column. That's actually how dark it was when we looked at it. We have some example cases of, I think I can take a look at these. Some of the discrepancies that we had, I think I still have them on this run. And you, okay, this was when I was running these other ballots in this case. So what we're doing, this is the ballot marking device ballot for ES&S system, the express vote ballot, and it encodes in these barcodes then the XY coordinates of the timing marks on the style ballot that it is. And in this first barcode, it says what the style is, but it's a different number than that style 53 that I showed you just a minute ago. It doesn't say 53 in here. It's a different number completely, and it's something that is a relation that we don't know about yet. But you can look it up by knowing the town of Cottage Grove, wards 1 through 7, and also includes these other races. The Stoughton Area School District board member, that contest. I wanted to show you some of the ones that may not have preserved since I did the run, and that's not good for this. Okay, so here is an example of where we did a better job than they did. You can see here that Jennifer Nashhold has a vote, but they did not see it because it doesn't go into the bubble. For some reason, people can't always hit the bubble very well. Some people will have a problem with always getting it off to the side or something else. This person, they went right above the bubble and they didn't see it. We did interpret that one correctly. Let's take another example of a misinterpretation where we had a disagreement. Same kind of thing here, where our machine said that this was a vote and they said it wasn't a vote. So what we have also implemented is a thing called adaptive mark thresholding. And it depends on the ballot, like how dark these are going to be. And we also include a little bit more of the area around that bubble because we think it's only fair to let the voter miss it a little bit than they do. They have a hard threshold, and that means sometimes when you have hesitation marks, it's not going to pick it up offhand. I don't know why this, oh, it was because of this hesitation mark. So in our adaptive thresholding, we see a big difference between how all the other marks are on this ballot when he or this voter voted and this one. However, ES&S called this an overvote. They decided to make that a vote and cancel out this voter's vote for, obviously, Lisa Neubauer should have been awarded the vote. We're at about a 99.998% accuracy. We still can make progress. We have some plans to do a little bit better. Let's look at another example of where we disagree. And I think it was this one here where it was just a little bit off. Again, most of the time we pick those up and we interpret them correctly, whereas the ES&S equipment was not. In this case, let's take a look at the report. No, that's not the folder I wanted. Okay, so we processed, in this case, 14,444 ballots. There were 12 different styles of ballot, and we had 12 that disagreed. As I showed you, most of the time, if we take a look again, like here is where Robert Whipperforth, we said that he got a vote, and they said he didn't get a vote. So we can take a look at Robert Whipperforth and see what happened there. So in this case, the line, the vote as done by the voter, you see, was just, it's legitimate because he tends to do this for every mark. He does it the same way. So we awarded that to Robert Whipperforth, but ES&S did not. So this is why we're pretty happy with our results, and anybody can check to see that our system is being fair, because you can simply take a ballot, modify it, put it back through it, and see if we pick it up. So then let me just finish up the process. I guess I was hoping this would be done by the time we got to this point, but I've been able to show you those cases anyway. Finally, the last steps of this is after you take a look at those cases where you say, okay, that is a case where, you know, I think that the vote by our extraction was correct and they were incorrect, or it may be the case where we got it wrong, which is less of the time, but sometimes at this point we are. There are cases where either there's a crease in the paper sometimes that gets the machines to think there's a vote there. The main thing, though, is to say, okay, well, what is the margin and what are the disagreements? And if the disagreements between the two systems is far less than the margin, then we're not going to catch, we're not going to catch anything. We are going to be setting up a way to add, adjudications, or basically a list of disagreements where the human has reviewed them and said, that's okay, or which way should it go. And then once it's reviewed, then we don't have to review it. At least you know which ones you've reviewed. But in the case after going through 14,000 ballots and only having 12 ballots to look at, and realizing that, you know, the auditing software is doing a better job, and it should be able to do a better job than the small scanners, because we have, you know, more power behind the system that we're using. We're able to, you know, utilize more you know, horsepower of the computers. So again, at this time, we're looking for counties that want to try this, get the ballot images together, get the cast vote record together, create an information file which basically just says the information that's on the ballot, so we can make sure that we can match it up, and we'll run it through. It does take time right now, and just, you know, looking again at this thing running, you can see it takes maybe a second or so per ballot to process them in one by one. This is only the interpretation phase, and this is only processing hand-marked paper ballots, not the BMD type in this particular run. So that's how long those BMD take less time. We can process those faster than this. But it takes us this amount of time because we're actually reading the text on the ballot. Originally, you know, I will say that at this point, no, we're not. We're actually going into, we've already read the text. We've already figured out where the bubble is and confirmed it that for this ballot, this is where the mark is going to be. At this point, we go in and we take that mark out and then figure out through this adaptive thresholding. So we don't decide what the mark has in it until we've collected all the marks on the ballot and decided what the threshold should be. If you can see it as it goes by up in this part, there is. Maybe I can stop it just by holding it. Hold this thing right here. Yeah. Well, maybe not. But I can't put the cursor over there, but you can see in the middle of the screen it says threshold set to 241 and 240. That's for that particular ballot. That was the threshold. So it sets the threshold for every ballot, and what we're going to be doing is biasing it so that I want it to go by now. Again, it's hard to do that. Is basically biasing it so that we give the benefit of the doubt to the voter. So in other words, if any of the marginal, let me put up another figure here so you can see how we're doing this in a way. So this is an example of a ballot. And this is from Wakulla County. You can see that the marks that are not filled in are a pretty low value, and the marks that are not filled in are filled in are relatively higher value. These are all ordered according to the density. And so you can say, well, here, obviously, you know where to cut it off. You know that these are all not filled in, and those are. But a different ballot may have a different density, and you may want to do it at a different point. Let me show you a different case, which is one I was trying to figure out, which has a little bit of a marginal case in the middle. Basically, it's this case right here where the lower values, well, if we just take a look at the values here and chart those really quick. I guess I don't have that chart made, but there it is. So essentially you can see that there's this one vote here, which is in the middle. Okay, we're not sure if it is a mark or not a mark. So in the case like that, when you have one that's in the middle, it could be a hesitation mark. What we want to do is we want to put it, bias it toward not causing an overvote. So if this vote here was the only vote in the race, then we accept it if it's below the vote for number. And if it's gonna go over the vote for number and cause an overvote, then we say that it was a hesitation mark and still let the other vote go through. So that's how we're going to be able to even improve over what we're doing now. Okay, so I see we've exceeded the time again. Let me see if there's any questions from the group here. I can't get you into the video other than your voice. Well, maybe I can. Let me see if I can move this little tab thing over. Yeah. Okay, so maybe you can see yourselves on the video. Yeah. And so go ahead, John. Did you have something you wanted to say?
Yeah, I was, well, great presentation. I know you're working on perfecting it. I was very, very much interested when it came to unders and overs because, ES&S and their aggressive sales approach says, hey, you won't have those problems. You go ballot marking devices. But realistically, do you have any statistics to show, that out of 100,000 ballots or 10,000 or whatever the number would be, what percentage you're finding this? Because, it is important to get it down to zero, of course, but it just proves that ES&S is full of themselves because we know that every time they sell a ballot marking device, okay, let's put it this way, every $1,000 they spend on new equipment, $720 is going towards replacing a pin.
Yeah, so I can say, oh, this is nice if I get you guys on here too. So in the actual recording, even though I'm a fixed figure here, they'll be able to see my picture. So as you can see here, we had essentially, this I don't think is correct. I don't know why it's not having overvotes in this run. It could be just the set. I'm not running a full set, but there were some things going wrong here, like this one. Is this there were still some cases where we got the timing mark off. Sometimes there's something like what happens sometimes, a complexity that is difficult to work with is occasionally the ballot will pause in the scanner right at the beginning, and typically right along in the first inch or so. And at that point, because it pauses, the scanner keeps going, creating additional scan lines, and it makes it look like it's stretched. Yeah. But then what you have to do is you actually have to use these timing marks. They're really important because then the timing marks, you can come down and say, okay, where is even though it's stretched, where am I? Where are we on this piece of paper? Because the timing marks will be in the same location. So it is critical to have timing marks and some reference points where you can double check where you are. I would say out of, like, as I said, in this one, we have 14,000 ballots. 12 of them we didn't match. And of those 12, about, I'd say 3/4 of the time, we got it right. And they missed. And those are, we're talking about small potatoes, really. because the overall margins, and in this particular report, it doesn't actually give you the margins, but the overall margins, are thousands of ballots. Here we're only running 20 precincts. So we would have to go roughly, this is 14,000. We'd have to run it almost 10 times, 11, 12 times more to be able to get them all. And of course, until we get the express vote ballots are easier for them to read. It isn't really easier for us to read them. And the reason is because we have to try to read every single one of them. Okay, if you get my meaning, like in this type of ballot that you're seeing here, we can stack them up and do other kinds of image manipulation to do away with some of this background mist that goes on and try to read some more of the text. But for a ballot summary card, you can't add them up like that. So you have to read every single one, and we have to do the OCR on each one to verify that it matches the barcode. So for us, it is still quite a bit of work, but it still is faster than doing these. So far, well, we're going to have the accuracy very high on those as well. I think that, there isn't the question of voter interpretation there so much, because it's printed exactly what the voter voted. And so we don't have to wonder whether the mark was filled in or not. But I don't think that interpreting that mark is all that hard. So all of the talk about how much easier it is, and those charts that I showed you about interpreting whether it's filled in or not, is better if you can do it with an adaptive approach, so you can see. And the reason is because some of these ballots are printed darker than others, or scanned so they end up being darker. And so you need to have an adaptive approach. In terms of numbers, we're still talking about the difference between what we do and they do. And also the question is, maybe sometimes we're both missing a vote the same way. And if we both miss the vote the same way, then I dare say that the person didn't get it close enough to the bubble. I mean, there has to be some reliance upon the voter following the instructions and filling the bubble in. A lot of times, they may have mechanical problems with their hands and they can't get it to that spot. But, the goal is to review and have a consistency check, and that this is what is working. Now, I just wanted to point out one more thing. When we do the cloud-based system, we'll be bundling up probably one precinct at a time and launching it off into the cloud service that will run and execute this across. So we'll be able to execute it over all of the many precincts that are involved. So if you look at, let's see here, the ballot set for Dane County, we have spring election. Yeah, if you look into these, so in one of these archives, we have 50 different precincts. And we have 5 archives. So roughly speaking, we have approximately maybe 250 different precincts. So essentially we could be launching 250 processes into the cloud-based service and asking that service, that's called Lambda, to fully process one precinct. It would go through one precinct, maybe take 5-10 minutes to do it, but then all the precincts will be processed across the entire district after 5 or 10 minutes, instead of taking 36 hours, which is what this is going to take right here. And then after this is done, it actually isn't done yet, because after we create our own cast vote record, which says this is what we think the result is, then there's a comparison phase where our cast vote record is compared with the official one, and then we get the differences. Jim, did you have a question? It looked like you were holding your hand up.
Yeah. Have you ever been able, or John, have you ever been able to get the ballot definition files, which would save you a lot of work?
Oh, well, let me answer that, though. We don't want to use their ballot definition files because we don't want to rely upon that information. It's too easy for it to be wrong. And then, like the coordinate of a bubble on the page, whether you're looking at one bubble or another one, if you look at one of these ballots, if you got the election information file, it would say, okay, now you can see here, this is a good type of a ballot because the contest does not have a gray background. It's going to be so much easier to verify that indeed this is the contest. Now, but if they're providing, what they would provide is basically they would say, okay, they go 1, 2, 3, 4, 5, 6, 7, 8, 9 over, and 1, 2, 3, 4, 9 across. So this would have like the coordinates of 9, 9. We might get that from them, but then what good would it do? Because we'd still have to go in and verify that Michael Huffman is indeed at coordinate 9, 9 that they said. And so we really can't use, I originally was thinking along those lines, so I appreciate your thought on that because it seems logical. But on the other hand, it would be very easy, for example, to give these two the opposite coordinates and swap the results for the two candidates. If we relied upon their coordinates, then we would also rely upon whether or not they had already swapped the coordinates over. And then we get exactly opposite results, just like they got. And then we would say everything's fine because it matches what they got. So no, we don't want to use those configurations. However, we do have to use the basic information, which is what are the contests in the election and what are the options for each contest. That is information that has to be known, and it's known ahead of the election. We don't need to know where they are so much on the ballot as what is the order of these things on the ballot, which contests are in what order. We don't need to know the order of the options. That can be figured out. But what we've discovered is that it's difficult to take all of the contests and say, it says town board chairperson here, which one is it? There's many town board chairpersons amongst the 300 some odd, contests. And which one is it? Are we sure that we're getting the town of Albion? So what we've figured out is that for a given style, this is style number 1, we need to know what contests are in that style. And it's available. They know what contests are on a style, not where they are, but which contests are in a given style. So that's a level that we are using now. And yeah, I think that what we'd rather have them work on is get the ballot themselves so that it's clear, what you're seeing is clear. The Wakula type ballots, and let me show you that because they are a different format. And tend to be much harder to read. No, these are actually fairly easy, but you can see that what they have here is sort of the all-in-one format where the title of the race is at the top, and then options are just all listed in the same box. But here's where you see here where First District Court of Appeal is the same name over and over. And in fact, that's what's in the cast vote record. In the cast vote record, there's no way to tell these apart. They just happen to be, you have to know that they're in the same order as what they are on the ballot. So those are the kind of problems where we need these names in the cast vote record to be unique and to make sure that we know which ones are which. This has been the lion's share of our problem, and is completely a different problem than I thought it would be. I thought it would be the imaging problem and trying to find the bubbles and stuff like that. No, it's actually figuring out what the contests are and making sure they're matched up amongst all the different 350 contests. That's the hard part. So any more question before we end the video? Any more?
I will just say, Mimi Kennedy and I have been bugging LA to get rid of the QR codes and so on. And their basic response has been that trying to read the names off the ballot is too slow. I've been doing a little math, and if you put multiprocessors on this, you're starting to get in spitting distance of getting results that could come out in a couple of days. And keep at it, because if we want to get rid of the QR codes.
Well, I don't know if, I think a better direction would be to go to the hand-marked paper ballot instead of this ballot marking device. Because even if you don't have the QR codes and you just have the printed names, it still doesn't give the voter the information of what did they not vote for, and they didn't see it in the lousy user interface. It only shows them 4 at a time. I mean, this is a problem where we have the ballot summary is an incomplete record. I will say also that a lot of times on the ballot summary, especially on the ES&S equipment, it'll truncate the name of the contest so that you can't figure out what it is. It'll say something like, Edgerton School District Board Member seat, should say 1, 2, 3, 4, or 5, but the number is not there. It's because it's been chopped off at column 51. So I don't know if they're going to have those problems with the VSAP machine. We will be able to read the VSAP ballot and the QR code and verify that they're the same. The problem is not that we can't verify that I don't think the problem is with the QR code itself or with the way the machines are interpreting it or our inability to audit them. We can do all that, and we can make sure that they're not cheating. The problem is that the voter can't verify what they've done. They can't tell that all of the things are there. So from a voter interaction standpoint, these ballot marking devices are pretty bad. That's my point of view. I think that they don't provide the full list. It would be better to go with print on demand, hand-marked paper ballots, and maybe for this election we could get them to install printers, have PDF files of every ballot, and just print out a hand-markable paper ballot instead of, if anyone wants to not use the machine. That would be one option. That's my point of view on it. Okay. All right, good. So thank you very much. Let me end my video here. I don't know how to do it now. Oh, here we go. Okay.